as soon as there's any change in any requirements, or it's literally is it's advancing, science advancing, technology advancing. We want to pivot as fast as we can, and also we want to ensure that everything that we're deploying is of the highest quality. Not because from the FDA regulation, which we are kind of tied to, but also from the customer satisfaction, both internal and external business users that cannot use our systems. So when I started in FMI a year back, we were adopting DevOps. And what does that really mean? I didn't really know that, because I kind of understood Agile. I also understood continuous integration, but what does that really mean, in DevOps? Because now the definition of done was, the complete software in production in that one sprint. That was a scary thing to, manage, both from the quality standpoint as well as the dev standpoint. So we made a lot of inroads in, getting there on the technology front. But it's this community here where kind of opened my eyes to what are the different things that you guys are doing, as well as what are the different things that you're doing in your companies, as well as what are the the best practices that you've adopted in this whole DevOps strategic move or mindset that you guys are doing. So I mean, yes, there was a good thing that we had the successes. We shared the successes, and we talked about the different tools and processes that we adopted. But the most important thing was the failures, right? And that was a pretty cool thing. You talked about the failures and how did we fail, and how did we fail fast and fail first. And that was a learning that was really eye-opening, because I kind of went back to my team and started looking into this guy's tried this, let's try this. It doesn't really affect us so much. It does affect us so much, but we could fail fast. So the framework that we went on trying to build and anything of that sort, and just being open to adapt to new processes. So this community here really helped, and I really want to thank Matt, Costa, and Julie for making this happen. Also Dave and the team to make this coming here, and also if you have any more questions on the science side or on the technology side, on the DevOps side, we have John Cassidy there. He is heading our DevOps strategy. We have Nick from Palo Alto. I think he's speaking in in the 4th session, but that's Nick there on the dev side, who's helping us move there. So and then you can just reach out to Matt again, me, and if you have any more questions on any of those 3 things.
Awesome.
Yeah, thank you.
All right, thank you so much. And just a big round of applause to the bar and also the foundation team. You guys have been awesome hosts. Thank you so much for tuning back into the community. Just for foundation, can you just put your hands up if you're here, so everybody in the audience, if you have any questions, feel free to do a sidebar after the presentations and introduce yourself. Definitely doing some really cool stuff with a really great mission here. So. Some really good rewards. So you can feel that you're contributing back at a higher level, working for a company like Foundation. This brings me up to my second announcement. I want to introduce you guys to Miles. Miles is one of the co-organizers for DevOps Days Boston this last year. He's going to be talking to you a little bit about resilient coders and our boy David Delmar. Del is trying to put together a program for kind of a DevOps type, I'm not going to say certification because we all will smash that concept, but he wants to tell you a little bit about their mission, what they're doing, and then they're looking for instructors to help in mentoring some of the young engineers coming into the business. So without further ado, here's Miles.
Kind of stole the show and gave my announcement for me, which is kind of awesome. Means I get to talk less. But Dave Delmar, he was trying to be here tonight, just couldn't make it. But Resilient Coders is a fantastic organization for disadvantaged or less advantaged youth, trying to get them through and into the meritocracy of tech and get them into jobs. Dell's an awesome guy. It's a really cool program watching what they've done. He started on web programming and trying to fill the need there and trying to get these people jobs. Because as we all know, the tech field is pretty much expanding constantly. So that's what this education program is coming out of for the operations and DevOps side. I haven't talked to him much about it yet, but I'm super interested. And if you have any ideas or want to get in touch with him to help out as like an instructor, especially if you're a freelancer, absolutely call me out and let's talk later on. Thanks.
Awesome, thank you, Miles. And if you guys are looking to get a hold of Miles, we do have a Boston DevOps Slack channel. Just ping us on the meetup site and we'll be able to get you linked into that. That's where the whole community is able to use the sounding board. If you got any ideas, thoughts, questions, or you just want to be able to connect with some of the members, it's a great place to do it. All right, hey, listen, a couple other things. I'm not sure if you guys know, there's an all-day DevOps online virtual conference. So I wanted to do kind of acknowledge that. It's going to be November 16th, and it's a remote access in. For anyone interested, it's going to be at www.alldaydevops.com. And you've seen a lot of promotions on it. Again, it's in the Slack channel. Nick was good enough to put it up in there last week as well. So it's a great event, going internationally from Germany all the way through. I think we got speakers from Australia as well. So it's got pretty much everything that you can think of content-wise, with some top contributors actually going to be speaking to the topics. So definitely check that out. All right, now I want to call to the stage our first presenter for our spooky horror show. Right, so what is this concept of living DevOps? We got this idea actually from Glenn Grant and Peter Beeland at the G2 team. We tried to do a little thing after one of the events, realized this is actually a topic or a platform that we should probably host as one will meet up. The idea, talk about what you were trying to do because it was really cool and what the result was, and really sharing in how you kind of got into the situation you were in, what you got yourself, and how you got out of it, and most importantly, is the lessons learned from those experiences, right? In the true fashion and passion for DevOps, sharing those failures and allowing others to learn is why we're all here. So, put the hearing on, and without further ado, I'd like to introduce you to Nick Simmonds, who will be speaking on It's Alive. I'm going to give Nick a second to set up his machine, but this should be entertaining. He's a slam poet. So, he knows how to get in front of an audience and entertain. That's all I got, Nick. Do you want the mic?
Yeah.
Okay, I'll leave it up for you.
It's alive. Oh, there we go. Now it's alive. All right. Tonight I have for you two tales of horror. Tools that got out of control, meant to help but only harmed once released into the wild. A little bit about me. I am an operations engineer who's been at this for years. I'm currently the lead at a company called Data Risa Incorporated that you won't have heard of because we existed for about 7 months. I also do private consultancy, and I am, as you just heard, a semi-professional poet in my spare time. Our first tale tonight. Think about the cuddliest, friendliest dog you've ever met. And how much you loved it, how much you wanted to pet it, how much it seemed like it never hurt you. Because, of course, a dog is man's best friend, right? Oh no! Until it goes bad. We all have had tools do this to us, right? We've all built something that we expected to be only an assistant, and then it went out of control. Tonight's tale is about one particular tool that I worked with at a company that will remain nameless because of an agreement I signed. but all names will be changed to protect the innocent. What went wrong? Well, so this tool was built to reach out to Amazon and scale our infrastructure up based on information it was fed. It sounds great. It was great when it worked, but this tool, it had no safeties built into it. It was just assumed that everything would work properly the first time. It didn't check its own input. You could give it garbage, and it would gladly reach out and do garbage. It had to run at highest privilege. It had to be able to do anything, which meant that it could do everything, and anything that does everything can be very, very bad in this situation. Item potency is a thing that comes up a lot. Not everybody knows actually what the word means. So what it means is that if you run it, it will do the same thing every time. Now, nothing ever does the same thing every time, but you aim for that. This tool did not work that way. It would often just like run off and do crazy things. It also had to work within the constraints of an environment that was kind of poorly designed. Servers that spun up in Amazon would not reach out and get their own code. You had to push code onto them. And this will come up in a minute, why this was bad. And then there was no documentation. Nobody knew how this worked. Somebody built it, handed it off, said run it, and go.
That's probably fine.
And in this particular case, the guy who built it did that, handed it off, and then went on vacation for 3 weeks. So to briefly describe the issue, one of the problems with this thing was that it would reach out, it would scale up infrastructure, and then it was supposed to deploy code onto the existing servers, onto the new servers. And then later, when we didn't need the infrastructure anymore, it would reach out and would scale down the infrastructure, terminating oldest first, which is by and large a pretty good practice. But it didn't check whether it did all of those things. So it would gladly take a service that was running on 4 servers, scale it up to 8, forget to deploy code to the new 4 servers, and then terminate the good 4 servers, blowing up the whole environment. We ran it for a couple of weeks, and it became very obvious we had to fix this. So, how did we fix it? We did get to the point where we could use it. We built guardrails into it. The first thing that I built, this is the last thing I did for this company, was I built in input validation. You could no longer feed it like just random information and have it do random things. It would go ahead and check whether the information was good. It would check that the environment was healthy, and if it wasn't, it would do nothing. It would say, this is no good, go fix whatever's wrong, you idiot, and then you can go forward. We documented what it does and how to operate it. That's important. Testing. Treat your automation tools the way that you make your developers treat their code. You wouldn't ever let them deploy something onto production without testing it. Don't build a tool and assume that it works the way it does on your laptop. Once it was done, we were in pretty good shape. It actually became a really valuable part of our toolkit. But it needed a lot of work after we put it into production, and it destroyed the world. So that's the deal. Like these things the automation tools are very powerful and they're very important, and you need them. But you need to have control of them. You need to have muzzles. My second tale of horror is about infrastructure designed by developers who decided that when it needed something else, it should just go build that other thing. If it needs an SQS queue, it just goes and builds an SQS queue. If it needs an SNS topic, it just goes and builds that topic. If it needs another server, it builds that server. Sounds great. You never have any sort of dependency that doesn't get met. But nothing stops the blob. We ran this over and over again and test, of course, as one does, as one should. We didn't realize some of the side effects of that. The problem is we rolled in a tool called Datadog. Great monitoring tool. I love it. But the problem with Datadog is, in this situation, was that it reaches out and checks all of your CloudWatch metrics once a minute. And we had 80,000 CloudWatch metrics that we didn't know about. The first problem was that the code required that every instance be able to create anything that it needed. It was designed that way. I can't fix it. It's just like that. We'll get to it, but for the moment, I have to work around that. No one knew it was doing this. It would go ahead and create like 5 SQSs every time you ran it, and then try to destroy those. And if it failed, no one knew. We didn't realize our Amazon costs were skyrocketing the month after I put monitoring. Because we're brand new, we didn't have those alerts in place.
You had all the money though, so it didn't matter.
Right. It was really hard in AWS to figure out what the heck was going on. Our issue turned out to be API calls. You might have never run into this. Amazon charges for API calls per region after 2 million. If you multiply 80,000 by once every 10 minutes, by a whole month, you rapidly exceed 2 million. That is such as this is my fault. I assumed that I would be told if anything was building something. That nobody would just like reach out and build a bunch of infrastructure, and that certainly they wouldn't build tens of thousands of pieces of infrastructure without telling me. And bad communication. I, the infrastructure guy, did not know the infrastructure worked this way. Nobody told me. So, nothing can stop the blob. What do? You set up alerting. So that now we know. Now anything that goes out of control, we've got alerting around it. I've got an idea of what's going on with the environment. Got it on costs. Anytime that the costs exceed X dollars per month, I get an alert. And I can move that alert around, but at least I got something. Got it on creation. Anytime something's created, now I get that information. Got it on changes. Anything that changes AWS infrastructure, that information flows through me. So the devs can't just go and fiddle with things. And we've got alerts on a handful of other things, but it's a lightning talk on that. Isolation. We broke the dev sandbox off into its own AWS account. We actually now have 3 accounts. We have a dev account that the devs have full access to. They can do whatever they want there. We don't have any monitoring or alerting on that account. So, if it blows stuff up, it's on that. We have a test account where they can log on to instances, but they can't make changes to the infrastructure that can't be made from the instance itself. And then we have a production account, and nobody has login privileges to that. I don't have login privileges to that, because if I can't get into it, then, that's as secure as I can make it for you. We started a meeting. Every week we have an ops meeting. I pull the devs in and I ask them where their pain points are. I tell them what I've been doing. They tell me what they've been doing. And every week I find out some new harebrained thing that they have done. but at least I know that they have decided that their code needs to be able to do another thing. And it's fun. I don't want to be a blocker. I want to be a bottleneck. I want to slow them down, but I don't want to stop them from iterating. In the future, we will fix this. I have told them, I will put my foot down. I will leave if you don't rewrite your code so that it can't just create things at once. We're not there yet, but that'll happen. So, now, it does do these dangerous things, but it's isolated. It's not allowed to reach outside of its jar. So we're relatively safe, and should the jar break, we'll know. So, this is where we are. We figured this out. We know how to treat our tools going forward. We know that in the future, everything needs to be tested, even automation, no assumptions. Everything needs to be communicated. That's what DevOps means. And that everybody needs to be on the same page about how all of it should work. We're in pretty good shape. Yes.
Awesome, thank you, Nick. So what we're going to do is, just so I forgot to announce this in the beginning, we're going to have all the presenters present their topics, and then afterwards we're going to bring all the presenters up as a panel for Q&A. So if you have questions, please either jot them down or just hold on to your questions until after all the lightning talks, because a lot of times some of the questions that you may have will evolve through the other talks, or you'll actually get an answer through the other talks. So thank you, Nick. Very entertaining. Really appreciate that. Now, I want to introduce you guys to David Blake Edelstein, who's getting himself set up the day the Earth stood still.
I can't help it. Oh, this is working. That's awesome. Thank you, whoever's making that happen. 1 second. Okay, and I had to just do a quick sound test. Sound test. No problem. Just make sure this works. Sound is not coming out of this. Oh, this could be so sad. Sound out of HDMI? Yes, no, maybe? Try that out of the computer. There we go. There you go. There we go. That's perfect. Okay. So I'll start this again. Okay. Sounds working. Good evening.
Good evening.
Okay, I'm from Boston. I know how enthusiastic Boston people can be, and that was pitiful. Let's try this again. Good evening.
Good evening.
Much better. So my name is David Blank Edelman, and I am the technical evangelist for a company called Apcera, which you may or may not have heard of. We make this software that allows you to take whatever workload you want and run it in the public clouds or on-prem or move it around. And there's a policy engine that does things like guardrails for you, stuff like that. But I'm not actually here to talk about that. I was asked to talk about a story of horror. And the story I want to tell you from horror is from a previous employer. So I'm going to just simply tell you a story, and leave this up. But I'm not going to actually use the slides. I thought, so anybody who knows me knows that I am all about the slides. I'm all about the presentations and stuff like that. This time I thought I would push myself and try to make it all about the music and the sounds. So I'm going to have no slides beyond this, and we're just going to see if I can tell you a story. Now the story that I want to tell you comes sort of from, I'll just start this, comes sort of from the halcyon days. And I'm hoping that there are people here who remember this. A key part of the story that I have to tell you comes from my past. I've been doing this for about 30 years or so. How many people in this room know what NIS is or what YP is? How many people do not? Raise your hand if you do not. Great, let me school the youngins for just one moment. Can the rest of you hang out with me for one moment? So, we all know it like the land of LDAP and stuff. Once upon a time, the idea was that you had a whole bunch of machines and you didn't want to keep configs for each of those machines on every single machine. Right? So what you would do is you would have a server, and the server would have the config files, and it would magically propagate those files out, or at least be a place that other machines could query for information. Roughly okay? That's all you really need to know. So I'm going to tell you a story that goes back once upon a time. So here's what. So I just wanted to say this is a story that leads back to the days when Solaris roamed the Earth. In fact, let me tell you how long ago it was. One of the people here is going to be using my laptop, and we were transferring his presentation to my laptop. And so we did that using a little USB key that I have. I'm holding 128 gig in my hands. It cost me $30. And this is probably more memory than I had in the entire data center at the time that I'm telling you this story. Okay, just so we can get some sense of this, where we are. So this, it's going to be a little bit of history here. Okay, so if you might, let us go back to this time when I was running a group at this employer that I'm not going to mention. Let us think back, that far. I think I can do this. If you can just come back with me for a moment. Back in the day when I was running this group. So we were doing whatever it is that we were doing, I was with me and my team, and I couldn't tell which audio cue to use for my team. So you can decide whether it should be this one. Or whether you think it is equally likely that it was this one here. I know, you can decide which one you're thinking. I just want you to get this picture in your head.
That one.
Right? This one? You like this one better? Okay, fine, we'll use this one. So I was sitting here with my team, and at one time, one of us was changing a config file. Specifically, it was a config file on the NIS master server that was the information for passwords. It was in fact the shadow file. Okay, this is where it's going. So at some point in time, somebody changed that file and came to me and said, "I think we have a problem." And I said, naively, "What's the problem?" Well, I seem to have messed up the shadow file that contains the information for passwords and things, and as a result, we can't seem to get SU access. We have no sudo, we have no admin access. We can log into the machines, but we have no administrative access. And I was like, that's bad. So on what machines? is what I said. And they looked at me and said, all of them. So that's usually not a good thing. So the first thought I had, I don't know, so let's just see if there's anybody here who knows where this music is from. You probably don't know. I didn't know. The first thought I had, and I'm going to be honest with you because I can remember this very clearly, is I'm sitting in my office, because I went back to my office to just mull this over. The first question I had was,
Run.
how long, well that was a question, should I run? Should I quit? Should I write that letter out? Or should, the question was, how long before anybody notices that nobody in my group doesn't have any administrative access and can't do anything? Is it a day? Is it 3 days? Is it a week? And that was, by the way, something from the movie Groundhog Day. Right? Because I knew that, because I was really going through my head like, okay, somebody's going to come to me and say, I need a new user, and I'm going to say, okay, it might take a few days. Or anything at all. And so the question is, what do you do in that particular case? So I started thinking. Here's my thinking music. That's okay with you. I don't know what your thinking music sounds like. Mine is pretty funky. So I started thinking, well, what do I do? The problem is that I don't have root. I don't have any sort of administrative access. What am I going to do? The next question was, well, who does? The machines are all still running. Nobody that I know, nobody I knew had root access. The only thing that actually had root access was, well, root. And root occasionally does things on machines. When does root do things on machines?
When it's told to.
Yeah, when it's told to, but when specifically is it told to? When?
Run.
Yes, those people who said cron was absolutely right. It is the case that cron runs, and cron, unfortunately or fortunately, runs with root privileges. So the next question is, what is cron going to do in the next days that I have left in my employment at this company? Well, one of the things that it did is that it ran a piece of software they had that would go and attempt to determine whether or not the disks were full. Do you remember those days when your disks were finite? Right? So it would go up and run this script, essentially run this DU to try to determine whether or DF, and run this stuff. And I was like, okay, well that's interesting. Now the script was owned by root and I couldn't touch it, but then I looked carefully at the script and it was actually running, this is how far we go back, the GNU version of DF or DU. And guess who built that? That's right. I built that software. And guess who had still write access privileges to the software I built? Okay, so I hope that you guys are in your head are thinking about how you fix this. So here's what I did. I said, this is awesome. I can do something with this. So I snapped into action. This is my snap into action song. Right? I mean, the first thing you do is you rappel down the side of the building, then you write the script, right? It's just important to know that. So I snap into action, and I take and I replace the command du, that one, because I can, with a script. And what that script does is it fixes Etsy shadow everywhere, or whatever, whenever it runs. Now, because I'm awesome, it then does a du. Because it's going to finish its job, of course it does. So, congratulations, I go to sleep that night, thinking I'm going to still have a job. Around 3 in the morning, cron runs, fixes things, I can get back in, I know the disks aren't full, and everything is great. And then we go back to work, and this is what it sounds like it worked for me. Anyway, so that's sort of my story. And I'm hoping that from that story you spent a little bit of time in your head thinking about what you would do in this case. And I think that one of the things that was useful to me when I was trying to figure out what was going on with this situation is I have read a paper, it's really quite old, but it's still worthwhile reading now, called How to Improve the Security of Your Site by Breaking Into It. And that's what I did. And so the thing that I then did, by the way, the next thing I did, the next day was like, what else is running that other people can change that root runs, right? Like that's the first thing you do is you go back and you audit this sort of stuff. And this was so long ago that everything was groovy. But I would encourage you to contemplate this in your world as well. I would also encourage you to contemplate what will happen next time you have a situation where you have locked yourself out. How can you get yourself back in a way that is ethically, morally, technically feasible? Right? All these questions are interesting. So I want to just thank you very much, and that's my story for tonight.
David, thank you so much. It's very entertaining. So, hey guys, I want everybody to take a quick 5-minute break. Restrooms are in the back. If you guys need smoke, definitely head outside. Grab some food, and we're going to be kicking off in about 10 minutes, all right? And then, so just want you guys to get yourself refreshed, and then we'll start getting engaged again, all right? Thank you.
Very entertaining story.
Oh, thanks very much. I really appreciate that.
Hey, Matt, are you guys open to doing tours?
I need to just clean this up, and then I'm going to talk to you.
I mean, I think there's a lot of engineers here actually that are really interested, so I don't know, like...
Oh, yeah, yeah, I have been there too. Let me just say that.
That's what I'm.
Yeah, well, this is the
Or.
Yeah, that's a possibility, but you're going to be able to run the backup software.
Yeah, with the backup software.
Well, that's true.
Good.
And if you're running that backup, you have other problems. That's all I'm going to say. I remember those days.
Yes, so I completely agree.
So what I, yeah, so what I did is I no, because I had built the DU that we were running. Because at that time, with Solaris, instead of running the existing ones, you might go off and buy from the source, you need DU, utilities. So I had built the DU. And well, someplace where I installed it, that was, yeah, it was owned by my users. I built it and I installed it, so I still own it. No. This is something I built and had control over. Shut that down. leave my
HDMI to Thunderbolt.
How did you get here? Yeah, there's a bigger, like, it's not like as soon as I said that, your brain would go, oh yeah.
Yeah, no, but we've tried something like that. It didn't work. It has to an extent. The big thing was like because then it gets kind of it's not like and that's the thing. I don't want to especially from outside the sales and marketing teams to talk about. Somebody knows why they do things. I want to try and be like, hey, now we understand why you guys do that. This is how it affects us.
there is for sure. There is for sure. Yeah, that is.
Well, and that's the thing. You're only going to get one side of the picture, and that's the thing. Is then we become like every other engineering experience. We're only speaking for one half, really, with no perspective on what the other side is.
Yeah. No, I appreciate that. I appreciate your desire for diversity.
Well, and that's the whole thing, right? Because my whole thing is we got into this mess because of the lack of diversity and understanding what the other side is doing. We always sat down and focused on what we needed to do, why we needed to do it, when it needed to get done. So we started building these big walls, and then hey, nope, now it's your responsibility. What's in the workload? So that's where we're at.
Okay, I'll let you rock.
Yeah, and remember, we're going to be closing it.
Yeah, I'm not going to go there. Hi.
Hello.
Yeah.
All right, if we can just gather our stuff, get back into our seats, I want to introduce Stephen Vance, who is going to be our next speaker.
Well, there were two problems.
We're going to be launching this off in about 90 seconds, and then we'll bring Stephen out.
Yes, I think that would have worked. But also, I guess the other thing. Woo!
I can't read yours. I started, it took me a while, but anyway.
Yeah, not too much.
All right, if we can make this to our seats, I have Stephen over here. Stephen's going to talk about when redundancy becomes a problem. What? That's a problem? I don't know. I'm redundant all the time.
Okay. So I'm going to go way back as well. I'm going to go back to the days when cloud wasn't even imagined, when most companies didn't even have a data center. What they had was a server room. The computer at the heart of the server room, and I just realized this while we were going through a little bit of a nostalgic trip a moment ago, wasn't in Boston, but it was running Prime OS. Yeah. So imagine this. You're running, at the time, a fairly large computer operation. You're told, you need to design a server room. And we're building a whole new building so you can do it from scratch. And you have a huge budget. So let's go for it. Let's make it solid. Let's make it robust. And as you're going through, you realize, well, these machines, these that I'm talking about, they generate a lot of heat. And they're in these closed rooms, and that heat requires air conditioning. This wasn't one of those that had, like water coolant and other types of coolant in it. It wasn't quite that extreme. But, so you want to put an air conditioner in there. And we're talking these big honkin' Liebert machines, that probably made this panel look a little small, right? Well, we have lots of money. Why not put two? One can fail, right? And so they did. And everything's humming along, and everything's going fine. And you have this machine generating all its heat that's being all mitigated by these big air conditioners. And one day, they need to be serviced. And of course, you don't want to service it during the day because the computer is serving all these wonderful operations that can't be interrupted. Multi-billion-dollar enterprise even back then. And so the service guy comes in the evening as everybody else is going home, and they're like, hey dude, see you tomorrow. Make sure it's working, right? And he goes in there. And so one of the things here, though, is this is before the hole in the ozone layer was realized. You have some really nasty coolants in these things. CFCs, HFCs. And he makes a little mistake and lets a little bit of it escape. Well, because these things are in general toxic and a leak is not usually a very contained thing, these conditioners have a sensor system that as soon as they detect a little bit of these wonderful coolants, shut themselves down and ring alarms. And so a little tiny leak suddenly shut down both air conditioners, and because it triggered this alarm that said, I'm toxic, the repairman goes running for the door, opens it, slams the door behind him, and realizes he has no contact information for anybody on the operations staff. And the air conditioners have shut down, and we knew from some previous experience that the temperature rises rather quickly. When the temperature rises rather quickly, the computers start to shut down, because if they don't, they start frying their hard drives. And we even had one case where, this was also in the realm of, real mag tape that was used for backup. We had one case where it heated up enough, mag tape started to melt on top of the computer when it heated up too badly, in a case of a power failure. So things get pretty hot. And it's 9 o'clock at night, and he doesn't know how to call anybody, and he's locked out of the room. So he goes home. So I happened to have the early shift the next morning, and I arrived at 7 o'clock to find basically our entire multi-million-dollar sort of mainframe thing had completely shut itself down, and nobody knew how to get into the room when the power was out. That was part of the disaster recovery plan that nobody had realized they needed to make. What do you do to get into the room that has locked itself down solid because of a toxic leak? Sledgehammer. Actually, we discovered the room wasn't as well sealed as it was supposed to be. We actually went over the fake ceiling. And we got into the room because, he sort of figured out that it really wasn't that big a leak. Yeah, it was rather interesting trying to, we lost a couple hard drives. We had to restore a bunch of stuff from backup. Running the maintenance late at night so that we wouldn't interrupt production ended up killing about 3 days of production. And that redundancy, the air conditioner that was shut down being serviced, that leaked the gas, that was, the other one was running just fine, and it's the one who sensed the gas and decided to shut down. And so the redundancy was part of the problem that shut down the entire center. So next time you think about scaling and you think about making everything redundant, make sure that they're not interconnected in a way where the failure modes trigger a cascade. And there's a whole bunch of other things about the disaster planning and making sure you have covered all your bases and stuff like that. So anyway, that's it.
Thank you, Stephen. Now that's lightning talk right there. And as I said, any questions, we're gonna bring all of the presenters up afterwards, so we can really have a digging deep on some of the details on how the environment was set up for them to get into the situation they got into. Okay, now I want to call up our boy Nick from Foundation to talk about a little bit of disasters from the dev side. We've been talking enough about how operations want to control everything.
Thank you.
Let's talk about the people who build it and why they do it. So without further ado, I'd like to introduce you to Nick.
Check. All right, so thank you all for coming. My talk, is from the dev side. So let's see. So I've been around for, what was it, years? Years. Yeah, me too. And I'm from Palo Alto. I run a team that does the FMI. All of FMI is externally facing applications. So when we got here, when we started this team, we were kind of a shadow IT organization. Not only were we not, part of IT, but we weren't even in Massachusetts, right? We were in Palo Alto. So they really made us separate. So I don't know if that was by design, but that's the way it was. And I was told, hey, just go, just do what you do. So, all right, so yeah, I need some Linux servers. I'm gonna, define my technology. I'm gonna define how I want my continuous integration and deployment to happen. And along the way, I realized hey, wait a minute, no one else here is really doing that stuff. And I realized that, as I was pushing and pushing and pushing, ops was trying to help out as much as they could, but the more I pushed and the more I built out my infrastructure, what I was doing was alienating ops. Because they didn't know what I wanted to do. I wasn't keeping them in the loop on things. And my team like really like made applications that were hard for them to support. I mean, that's the truth of it.
What you do.
Now, huh?
It's what you do.
Yeah, well, I mean, yes, right? So, you know, like, we chose a completely different technology stack than anyone here. You know, it was, if you look back 2 years ago, we were, like, probably hated by ops. I don't know who's here who used to be there. Thank God, I think everyone is already in a meeting or something. So, but to their credit, like, they actually really tried. They really tried to support us. Like, damn, that was really cool. Like, looking back, like, what a bunch of cool guys to actually do that. And they're not here, so I actually mean that. So that's kind of how we started. And yeah, like I said, so what came out of that? Like, we did, on the dev side, develop some pretty cool stuff. Like, we have like a test-driven development, you know, agile team. You can't see it, but this is my talking points because I'll forget what the hell I'm talking about. You know, we were one of the first teams to have Git in the company. You know, was TFS, a very Microsoft kind of organization, which we just. I mean, I don't know that technology. I just went a completely other direction. We had releases every sprint, which, you know, is not enough, but it was a good place to start. You know, automatic deploys, all this stuff, right? But as I said, we alienated IT. It was impossible to support us, and I'm going to have the fastest lightning talk ever. So today, where are we? Yeah. Thank you very much. So we are now, so long story short, after a couple years, we've been moved into the IT organization, right? So now we're actually part of this group. We are, and it's interesting because what did that mean to us as developers? Did it mean we work nicely with ops? No. It meant now we have carte blanche to go do whatever the hell we want. And so we started trying to help, right? So we started running really quickly with like investigating new technologies because now our IT organization does want to move towards more of a DevOps model. And so, you know, as developers, we're like, yes, code all the things, right? And which is great, I guess, except that ops is like, slow down, guys, right? We're not there yet. We have a lot of there's skills that you guys are introducing that we don't have in our operations team right now, and I think it's scary. I think it's for them, it's frustrating for us, and as far as the technology talk, I'm not talking about technology because I think this all really comes down to people and how the groups interact together. So I think probably the biggest thing, the coolest thing that's happened is us really getting ops into our Scrum teams. And having ops up front in the planning meetings know what the hell's coming up has made everybody's life like so much nicer and cleaner. Doesn't solve all the problems, but it's a good place to start. And I think that's true of a lot of these, not just ops, right? There's design. We work on web UI stuff. So design also has kind of like an orthogonal like view of the whole company. QA, quality engineers, and even our data governance team. Like, so there's probably even more that we don't even think about yet, but we probably will in the future. But you know, out of all of this like sort of like long journey of like I'm doing it all myself. Okay, now I'm going to help you guys do it myself. it really comes down to like, let's work together, and how you do that is through this Scrum process, through actually, planning together. That's it.
Awesome, Nick. Hey, that is about as honest as you can get, right? Like, bottom line. We can definitely get into more context behind like some of the decisions that were made and the motivations through the Q&A. But before that, we have our last speaker. I want to bring up to the podium our friend and our contributor, Don, who's going to talk about some really scary stuff. What happens when your basic structure of everything goes down? I'm talking like no electricity to the building. Most of us would just, head over to the local pub right next to me, hanging out and be like, hey, it's somebody else's problem. But Don's going to tell you about an interesting experience and what they learned from that. So without further ado, here's Don.
I'm going to take us back to a very scary, spooky time. This was a time before self-healing infrastructure. This was a time before observability frameworks. This was a time before the cloud. This was 2014. Or at least it was Enernox 2014. We've since seen the light. We make software that heals itself. We have software that can tell us what it's doing and makes it very quick and easy to see what it's doing. More often than not, when the pager goes off for a new infrastructure, it's actually a race condition with the self-healing logic, and by the time I go look at it, it's already fixed itself. It's a wonderful world to work in. But we weren't always that way. We weren't stupid either. We had a legacy application. It was a monolith by all means of the word. It ran in a data center, but we had it on, we had multiple VMs. They all ran on redundant hardware. That redundant hardware was dual corded. We had 2 independent power feeds coming into the building. The upshot of that is if we ever lost one, well, the other one's there. And we even had some very enterprisey looking hardware. These were machines with power interrupts. The whole idea of a power interrupt is that these power supplies on these servers have huge capacitors, and when they detect a power loss, they say to the operating system, flush the cache on the disks. So what could go wrong, right? So what could go wrong? Well, everything. Let's go to May 3rd, 2014. Our colo provider said that they were going to be doing power maintenance. And beginning at 6 a.m., we would lose one leg of power, it would come back up, and then we would lose the other leg of power, and we would come back up. Now, that's exactly what we were designed to be able to deal with. But out of caution, we even sent someone over to our data center to make sure that we would dual cord it properly, to really just make sure that we didn't have something stupid like both legs or both cords going to the same leg of power. So we felt very prepared. At 6 a.m. on May 3rd, 2014, the pager went off. And this is what I got. That's what I got. Wow, what does that mean? I don't know if anyone can read that from here, but there's not much to read. I have save search results, name say reading bean, query terms, index equals CDP prod say reading bean, link to results, some AWS IP. Alert was triggered because of the subject line. That's not helpful. What do I do at 6 a.m.? So luckily I knew what that meant. Being on call, you were just supposed to know what that meant. There was no run book. It was just something that you picked up from experience. That actually means that no messages are coming into our IoT platform from the field for 10 minutes. You wouldn't guess that it's that kind of severity just from looking at it. But, all right, wow, did we lose a router or something? That's bad. So I go to log into our VPN and can't. I go to check my email and can't. Well, if I can't get on the VPN, process says contact the network engineering team. So I go up to our company wiki, wait, I can't get on the VPN. Now what? This is where you are allowed your 15 seconds of panic, but only your 15 seconds of panic. That's the important part. Panic is good, but in small amounts. So 3 times a year, I sacrifice my hair to the DevOps gods. And they luckily, at 6:25 a.m., got me back onto that VPN. But this was not before I had started networking my way to phone numbers. I literally just called some engineers who were completely uninvolved that I just happened to have the phone numbers for and said, hey, do you have a phone number for such and such? In some cases they did. In some cases they didn't, but they said, no, I know Y's number and he might have X's number. So for 15 minutes, I was just calling numbers, trying to find someone who could help. Once I got onto the VPN, my email started downloading. Slide. So Exchange was coming back online, and wow, that's every server. That's 411 every server. Okay, that's bad. So all right, now I can get onto the wiki, right? No, it's still down. Okay, SSH the wiki, run etc jboss start, go onto the wiki, and finally go and get phone numbers that I need. And at this point, I have a good idea of what happened. I run uptime on that wiki server, and my uptime is 5 minutes. Okay, next slide. Here is a message from our NOC, inbound to us and to AWDL. The NOC is currently unable to access Demand Smart, that's our product, following an outage of all systems, including internet and phone lines. Please advise. Not an email that you want to get. So, now what? We haven't got a runbook for cold start. We don't know what to do in this case. We never planned for this. Luckily, as I said, we had a monolith, and we were still releasing quarterly. So one of the things that we did is in that runbook, we said how to stop the platform, how to deploy the platform, and here's the big one, how to start the platform when we were done. So I started running the release plan. I just skipped over the stop and deploy and started running startup from the release plan. And strangely enough, this actually got us a good deal of the way. So show of hands, who uses RabbitMQ? Okay, got a couple. Who uses eJabberD? It's a little bit more esoteric. All right, 1, cool. 2. Both of these use a database called Amnesia. That's very aptly named. Amnesia will forget about everything at the slightest sight of panic. That includes while it is mid-write to the disk. This is important. Amnesia is not consistent during disk writes. So if you lose your data, or if you lose your application while it's doing a disk write, you can kiss your production database goodbye. It's gone. So what ensued was about, I want to say, an hour of me trying to take all the nodes in our RabbitMQ cluster and get just one of them to start up. Maybe by the way replication worked, maybe there was a little bit of delay, maybe one of these nodes would start, and then I could propagate that entire broker configuration from that machine to all of the other machines. An hour later, I was pretty convinced this wasn't happening. So I got our IT operations team involved. I asked, please restore the offsite backup. That takes time. And remember what I said earlier? Amnesia databases on the disk are not consistent. How did we back up the Amnesia database? Well, we took a snapshot of the disk. Our backups were no good. We never tried restoring them. This is looking bad. By happy circumstance, I have from several months earlier a 17K JSON blob that was an export from the web UI. And out of desperation, I blew away on one of the nodes the entire Amnesia database, uploaded it to a fresh RabbitMQ through the web UI, and let it propagate. And that is how a 17K JSON blob on a MacBook saved the day. Let's see. So that was par for the next few hours. There were lots of horror stories in there, but I won't get to that. 4 hours later, the startup was done. The application was back up. Or was it? No, it wasn't. Because we didn't have a cold start runbook, I had just gone off the nearest thing we had. No, it was not all up. We got paged by the NOC 2 more times. And both of the times they were saying to us, this piece of functionality still isn't working. Please go investigate. That was part of our problem, though, is that we didn't have an observability framework. We couldn't tell what was down and what was up. Can we do the next slide? So it's time to learn from our sins. How do we atone for this? What do we do? The first one, we made the cold start runbook. We defined what steps that I did that day that we would need to repeat should we ever have a repeat. Thankfully, 3 years later, we have not. But this was an important thing, because not only did it get us into disaster recovery mode, but being the good DevOps engineers that we are, we automated the runbook. that was powerful because we used, or we have environments that look pretty much the same from QA all the way through our CI process up to production. And we now use that automation to shut QA on and off when we don't need it. There were massive gains there. Our releases up until 2015, we were still doing quarterly Saturday releases, and we were able to get our release time down by an hour and a half because suddenly shutdown and startup was automated too. Huge gains. Second thing, we got insight into what was running and what wasn't. We said, all right, let's build out something that tells us what is on and what is off. It seems simple, but we didn't have that. And later, because we're awesome, we have big screen TVs throughout the office. We made some dashboards and we put them up on the TV. It's great insight for everybody. Number 3, the numbers of everyone on call went into everybody's phones that was on call. If Confluence goes down, we have a way to get in touch with people. Even if we don't know who exactly is on call, you'll find the person that is. The 4th thing, we fixed our alerting. So why did the no data alarm get me? Why didn't, for instance, uptrends get me, which is the thing that would have made logical sense? Well, the no data alarm went off because it wasn't going through the data center. It was not going through Exchange. Splunk for us was this magical new thing that lived in this magical thing called AWS. And it didn't use Exchange to route mail. It used this cool thing called SES. And it could hit the pager when the data center couldn't. Why didn't uptrends ping us? Well, a year prior, we had Akamai'd our application. And it turns out that our uptrends check was actually checking whether Akamai was up, which is a total waste of time. So, number 5, we fixed our backups. Anything that has an export feature now uses it. We also test that we can import our backups, which is another good one. Next slide. We made our alerts mean something. So this is one of the newer alerts that comes from our new infrastructure, and this is again one of those race conditions that's basically fixed by the time I see it. I'm not going to read this entire thing, but it says, here's what happened, here's what you should do next, here's a link to the runbook. That's really nice at 2 a.m. on a Sunday morning. And finally, one more. Let's talk about the zombie bear shark in the room. So remember how I said we had a backup data center on the other side of the country? Well, why didn't we just fail over that? This would have been the clear time to activate all of our disaster recovery protocols and go into the backup data center. Well, we didn't know we could. It sounds crazy, but what we had taken to doing was, because of the machine shortage, we had started using it as a staging environment. And we had the disaster recovery environment configured as staging. We had something that was not production deployed to it, and we had zero confidence that we could actually get it back into a state where we could use it as production in a reasonable amount of time. For that matter, even once we got there, we had no idea if it would work as production. We had never really successfully tried that. So what did we do? We started treating this as a bona fide engineering project. We said, what do we need to do to ensure business continuity in the event that Boston goes away? Which, I mean, there's sea level rise, it's a major urban center, plenty could happen. And what we ended up doing is we enumerated all these issues. We started tracking them, just like we would any other software project. We started testing them, just like we would any other software project. Nowadays, we actually do, once or twice a year, go run out of our backup data center. All of our customer traffic goes to it. We can prove that this actually works and we have no dependencies on Boston. Now, oftentimes this doesn't work, but it's a test. This is how we figure out that it doesn't work. And this is how we triage the issues that we find, just like any other software project, that actually prevent us from being able to run our infrastructure. That's all I got. Thank you.
That was a great talk. Great talk. And it really ties in some of the business decisions that are made, and how in actual operations they work out. It's good to pay for a second data center that you don't utilize. But at this time, I want to call all the presenters up to the floor, and this is really where the value comes out of it. We want to host a question and answers from the audience, specifically to the presenters on anything specific that you want to address. And the biggest thing is this: look, if there's anything that resonated for you guys in your organizations, don't be afraid to bring it up, right? Because a lot of times you're going to have some answers or some suggestions, examples, potential solutions that will be able to work for you. There's no point in doing it by trial and error when you have a group up here of individuals that have done it themselves that you can leverage. So at this time, if you guys want to grab a seat, I would like to address the crowd. What kind of questions do you have for our presenters?
Can I make a quick announcement?
Yep.
Yeah,
hurry.
Sorry, just a quick thing I forgot in my talk that I want to mention. So, and this is just a quick plug. Coming up in December is Lisa, which is kind of the largest sysadmin DevOps conference in the world, and you should all go. And at that conference, I'll be giving a session about things that I've learned about this machine that was involved in my talk that is still running 26 years later. And what we can learn from that. It's called Lost Treasures of the Ancients. And I think you'd enjoy it. So definitely come to Lisa. So,
All right.
Back to the questions.
All right, thank you, David. Yeah, for those that don't know, Lisa, it's a great event. We have a lot of contributors that are involved in that. So, for the audience, any questions?
December, beginning of December.
All right, we'll start over here and move back a bit.
Boston.
Look it up.
Yeah, wow. It'll be on the Slack channel. All right, go.
I'm sure I have the question that everybody else here is thinking. Don, how was your DNS during that outage?
That was our DNS. Are you talking about our internal or external DNS?
I mean, were you partnered with Dyn? Was there a backup Ultra DNS or at Route 53?
We handle all of our DNS through Ultra DNS, so luckily not an issue. I am very glad though, because I did not even think of that being an issue for this to have happened.
Yeah, a list of top IPs that, like, to the machines you need sometimes is helpful.
Mick.
Yeah, so quick question for Nick. When are we gonna get some slam poetry DevOps? But before you answer, I'll just move on to my more serious question, which is for the last speaker. I've never seen a situation where you have 2 data centers and you shut one down to test what happens. I've seen, I know, for instance, TripAdvisor run 3 data centers all the time, and they frequently shut one down and flip over to the third because they know the other 2 can take the traffic. Sounds like kind of a risky proposition to only have 2 and shut one down and see what happens.
For the testings.
Sure. So to speak a little bit to that, the application which we post out of that data center there is an externally facing component. The primary use of that particular application, again, our actual customer-facing application, which is new to us, lives primarily out of Amazon Web Services. And of course, we are looking into being able to run high multi-regions for that. For the data center bound application, though, that's primarily runs out of Boston because its consumers are primarily in Boston. Originally, when we wrote that application, there were no provisions for being able to run in a basically multi-region environment. So while it is feasible, we did try this a couple of years ago, and what it turns out is that the application is nowhere near architected to deal with the kind of latency we see replicating data between the 2 data centers. Really, what would need to happen in order for us to be able to run hot with 2 geographically distinct data centers would be to reimagine how work is distributed across the pool. And that really isn't something that we've seen great need to do so far, just based on what's actually happening in that single data center.
I'm actually working on a poem where the first stanza is in Python and it outputs the second stanza. So when I'm done with that, maybe I'll bring it here and perform it for you guys, but that's not ready yet.
So, you started off talking about making sure that the power was plugged into the 2 different modes. What went wrong? What went wrong?
That was actually something I glossed over. Thank you for asking. Our data center provider said you are not going to lose power on both legs at the same time. It turns out that if you have 2 400 amp breakers and suddenly you put the other 400 amps of load onto the other breaker, that's more than 400 amps and the breaker's nuts. That's what happened.
All right, we got a question back here.
I honestly don't really have a question. I just wanted to thank you for writing DF to you.
All right.
I didn't write them, but I compiled them.
Is there any other questions from the audience? All right, hey, we want to first thank Foundation Medicine for hosting this great event. Thank you so much. Wonderful establishment here. Thank you to our presenters for their lighting talks. It's really, it is a little nerve-wracking getting in front of an audience like this, especially since, engineers are always going to judge. But again, we'll have all of our content on the meetup site, so if you guys have any questions, all of their contact information will be there, and I highly suggest everybody joining the Slack channel as well. Can we get a quick hand for David and the others who helped organize this? And for Matt, and for the foundation team. Thank you very much, guys. In closing, if you guys want to be involved in the community, we're always looking for new sponsors, new hosts to bring this event to. It's all volunteer, all the organizers, all the presenters. We're really trying to just get some word and some message out there about what we're trying to do and help one another, right? Because at the end of the day, we're an evolving community. And then the best way to keep ourselves strong is to be getting involved. So thank you again to everyone who's been a part, and thank you for everybody for participating. Really had a good night. Thank you.
Oh no, thank you, man.
Hey, great talks, everyone. I'm so sorry. I told your story. I was like,
actually wrote it.
like that's the guy who wrote DF and DU. That's awesome. I was like tweeted out like, check this guy out. He wrote DF and DU.
I only compiled it.
Like that's